Okay, so our unit 6, the new packet I posted, which I think on the packet it says section 8.5, is looking at exponential growth functions. How do exponential functions grow? What are their properties? Stuff like that. So we will start with just thinking about what is an exponential function. We know that an exponent is just a shorthand way of writing repeated multiplication. So if we have x times x, that's x squared. That little 2 there is our exponent. For an exponential function, it is a function where our input is the exponent. So the most basic version of this would be like y equals 2 to the x. So our function, our input, our x variable is the exponent. Exponential functions grow by multiplying. Right? We're multiplying 2 over and over and over, whereas linear functions like y equals 2 times x grows by adding. Okay, so if I were to have a table, turn that off, Zoe. And I have 0, 1, 2, 3, and 5, 8, 11, 14. Here, my y value, every time my x value goes up by 1, my y value is going up by 3. It's adding 3 each time. It's the same amount each time, so it's a consistent pattern, but it's growing by addition, and therefore it is a linear function. If I were to take that same starting point, Zoe Ann, and multiply by 3 each time, oh, what is that? 3 is 15. And now I'm multiplying by 3 times 3 times 3. So now this is exponential. The function here, y equals mx plus b, this number that it's growing by is my slope, and my y-intercept when x is 0 is my b value. This function, exponential, our general form is y equals a times b to the x. A is my y-intercept, and b is my growth factor. So y equals, in this case it's still 5, because that's my y-intercept when x is 0. Whatever y is my y-intercept, times, and now I'm multiplying by 3 each time to the x power. So you can kind of see how there's similarities between linear and exponential functions, but they're also very different types of functions.